Okay, problem number 6 has some weird numbers, but the setup is easy. In the diagram below, determine which segment is greater, RS or ST. So again, we see that the entire thing, RT, equals RS plus ST. So RT is 9n minus 5, that's a 9. And then RS is 5n, ST is 30. And again, we just combine like terms and use inverse operations. In this case here, we're on inverse operations. So subtract 5n from both sides and say 9n minus 5n equals 4n. And then add 5 to both sides and get 30 plus 5 equals 35. So 35 equals 4n. And divide both sides by 4. And you get a weird number here. N equals 35 over 4. This is 9.7, no, I'm sorry, this is 8.75. 8.75. So then we substitute in for RS. RS is 5 times N. This is 5 times 35 over 4, which gives us this weird looking number 175 over 4, which is 43.75. So RS is 43.75. ST is 30. I don't know why I told you what RT was. We don't need that for the problem. We just need to see that RS is greater than ST with this evidence. Okay, 2 more and then we're done. This next one has some quadratic in it, but it's easy quadratic. Again, we have to draw it. Point B is between A and C. So here's AC, B somewhere in the middle. Where AB equal x squared, BC equal 5x, and then our total AC equal 14. So one piece plus the other piece equals the total. Now we're quadratic, so we need to set the quadratic equal to 0 in order to solve. Subtract 14. Now here see that AC equal negative 14, B equal positive 5. So that tells us that we're looking for positive 7 and negative 2. So we've got x squared plus 7x minus 2x minus 14. That's x plus 7 times x minus 2. Substitute and get x equal negative 7 and x equal 2. Now look to see which of these roots we should use. If we use x equal negative 7 on BC, we have 5 times negative 7 is negative 35. We're not going to have a negative distance or a negative length for a segment. Lengths will always be 0 or positive. So we're not going to use x equal negative 7. X equal 2 will work. And we're looking for BC. So again, that's 5 times 2 is 10. Great job, Smarty Pants. Last one. This will be a little bit tricky. Okay, determine the length of FH. FH we see here, but we don't have this x plus 12 yet at the beginning of the problem. We don't have that 9 plus x here at the beginning of the problem. All we know is that GH is 9. Then FH is x plus 21. So let's show how we find FG. That's down here. So we'll say FG plus GH equals this total FH. That's here. Now what can we substitute? We can substitute that we know GH equals 9. And then we can substitute that we know FH equals x plus 21. So we have fg plus 9 equals x plus 21. And now if we subtract 9 from both sides, we have fg equals x plus 21 minus 9 is 12. So I can bring that in here. So let's see how we can figure out what hi is. It's the same kind of thing. We know that gh plus hi equals this total gi. We know gh is 9. And then we know gi, that's down here, 18 plus x. So we have 9 plus this unknown hi equals 18 plus x. Now let's get hi isolated by subtracting 9 from both sides. Hi equals 9 plus x. That's how we get this piece. Okay, now we're trying to find what fh is going to be. So we know fh is fg plus gh. So that's x plus 12 plus 9. And then we also know that that fh is x plus 21. Yeah. So we have to write a new equation that brings the entire fi, what we know about fi, into the mix. So we know the entire fi equals 14. And that entire fi 14 equals fg, which is x plus 12, plus gh, which is 9, plus hi, which is 9 plus x. So 14 equals the sum of all of this. Now combine like terms and get x plus x is 2x. And then 12 plus 9 is 30. So this is an easy equation from here. 14 equals 30 plus 2x. Subtract 30 from both sides. Negative 16 equals 2x. Divide by 2, x equals negative 8. Now substitute for what we're looking for with x equal negative 8, where you might be like, hey, wait, I thought a negative solution we can't use. Well, let's see if we can. You said that fh is x plus 21. Well, that's definitely true. It's right here. Now let's bring in x equal negative 8. Negative 8 plus 21 is 13. Could fh equal 13? Of course it could. And I'm happy we're finally seeing an example where our solution for x is negative. However, we can still apply that solution and get an answer that makes sense. Great job on this really confusing topic, Smarty Pants.